Howdy there. Welcome to Weekends Web App. This is day 9, if I remember correctly. I'm always getting the days wrong, but I'm pretty sure it's day 9. And this is a stream where we build a complete web app from start to finish. Although, as said before, finish is a relative term. We'll see when we get there. Today, we're going to be going into... Actually, before we do, if you're keeping up along at home, and you've got the repository on hand, you'll want to be checking out day 8, and that's where we finished off last time we worked on this. And anyway, going into what we're working on today, we sort of finished off our router. We did a bunch of code cleanup, if you may remember. Cleaned up our platform code. We had our router, and we split that out into a renderer plus a router. And then we just started to handle the concept of state within our system. So we'd have a clear way of what looks like the state shape for our routing and our counter. So with that state, that's our in-memory state. And this bears talking about because we did say right at the beginning that we'd have a couple of different aspects of our application state. And that's what we're going to be venturing into today. So we have our in-memory state. That's pretty much the bit we've handled. We're going to be using Redux for that. And that in-memory state is just for all intents and purposes, it's just a codified way for us to handle all the information that comes into our application and then flows through to our views. So that information can be rendered in a sane way. We don't end up with things like counters ending up out of sync or old data being displayed that shouldn't be displayed and whatnot. That's the purpose of the application state, the in-memory application state. The local storage and the local database, the intention of those states is to persist things beyond a refresh. So our in-memory state disappears. Every time we refresh, it disappears, it's gone forever. And that's fine because that's what we want. But for any application, you usually need to persist something, right? And a lot of applications, the way they work is they don't actually persist anything on the browser, and that persistence is on the cloud. So you'll see that every time you use stuff like Google Apps, when they're not on offline mode or Paper Dropbox or whatever, is when the application stops working or stops connecting to the internet, if you've got a patchy connection or whatever, it'll tell you your stuff is not being saved. And if it's badly put together, or like if it's not put together with the mind of using local storage or local database, and you refresh, that information is gone forever. So in that case, the persistence layer is that persistence layer is intended to be the cloud, essentially their server, their proprietary place where they keep all the information. When we build this, however, we're going to be building with an offline first capability. And what that really means is not necessarily offline first, but rather that the data stays with the browser first as the first sort of point of persistence. And then eventually we'll have some sort of synchronization ability where it will talk to an online service. And the idea behind that, obviously, well, not necessarily obviously, I should avoid saying that because it's all about relative, it's all point of view. Obvious is a bad word. But rather, the reason why that is because if you store it locally, then that gives the user control over their data. It gives them the ability to export, import if you provide it. And it means that nothing needs to necessarily depend on an outside service. Not a great business model, I will grant, but probably where most of our applications should go eventually. And if you look at how software used to be done is they didn't require online services to get all the things they need to. And I mean, still, this text editor is dependent on files. It's not dependent on a cloud to run or anything like that. And that's certainly the case for whole hosts of applications out there. And you certainly wouldn't expect anything less from a lot of the things that you use on a phone because you just can't be depending on the cloud for every single little bit of data. So that's what we're going to be talking about. And before we do that, though, I want to spend a bit of time with a notepad just to talk about the different types of persistence that we have available to us in JavaScript, or rather in the web in general. So while I did use the term local storage as sort of the moniker for this episode, it's probably a bit of a misnomer, mainly because local storage is so small a topic. So let's talk about persistence. Now, the one that potentially everyone knows about, if you've got some sort of exposure to the web, is cookies. Cookies are unique. Like, they were early on the scene, and they were a way to store information. And something that was very useful about them is that every single request, so if we have our server over here, and we have ourselves a client over here. So when we communicate with the server, the one thing that makes cookies unique to our other two options, local storage and IndexedDB, so the one key thing that makes them unique is every single time we talk to the server, our cookies go along for the ride. And that can be very useful for particular things that you can't actually do. Let me think of the best way to say this. So not every time, if we look at say a HTML document, like our index.pug. So here, right here, we're referencing a CSS file. And down here, we're representing a JavaScript file. And when we, so I'll run up my server, and we'll take a look-see. And I'll just do a shift refresh, and I'll look at the network tab. So this network tab represents how we communicate with the server. And you can see in this network tag a bunch of information that gets sent to the server. This is in request headers here. Now, if we were to, I wonder if application gives me a way to add cookies. Okay, so we've got no cookies right now. Can we add any? All right, we can't add any. So what I might do is quickly grab ourselves an extension. I could do it for the API, but the API is really not that great for cookies, so I'm going to do this instead. There are a lot of extensions out here, so this one might not be great. I want a dev tool for it. Cookie Inspector, that might be the one. No. All right, I'll just take this one. That's fine. Okay, so I just want access to the cookies and editing the cookies in my dev tools. Hopefully this one will give it to me, but if not, there we go. All right, let's take that. So let's add ourselves a new cookie. We'll call it test a cookie. Okay. So we're going to just add that cookie manually. It's all very well and good. Now, if we refresh now, and I'll do a shift refresh, what we'll see is in request headers, that cookie has gone along for the ride. If you see that right there, test a cookie and equals testing value here. And we could add another cookie just to show how it does separation. Some other token, blah, 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 blah. I'll throw some spaces in there just for good measure. All right, off we go. I might not like that. No, I didn't like that. So when we add ourselves our tokens here, and we do a refresh, you'll notice that here we've got a separator for like a semicolon separating each of them, and then we've got new values each time. So the thing that cookies can do that none of the others can do in terms of the standard is cookies get passed back and forth between the server and the client, which means they can be used as sort of a background variable for nearly every request. And this can be very useful if you, say, want to access control images. So if you had, say, an image source here, and it was just under assets, some image .jpg, doesn't matter. If you wanted to access control against that image, like let's say instead it was some media item, right? And it was private. And that media, you needed to lock access to it. And the only way to get information to go along with your request is for it to be bundled along with it. That's what the cookies can be very useful for. So that's where cookies sort of shine. That's still their niche that they're still useful for, and that's why they're also good for from a security standpoint. And that's only because of conventions by browsers. But essentially, there is an ability to also mark a cookie as HTTP only, which, from a security standpoint, if we were to edit this one, you can see here, host only, HTTP only. HTTP only means that only the server can actually look at it. No JavaScript can check it out. So that gives you a lot of, like, it's like a secure way to put a variable in there. But I mean, security is a relative term, because if you got not so good JavaScript jumping around your page, pretty much all the gloves come off. So it's really important to make sure that once your website is served in a globally available context, that it's you do diligence in making sure that your site is secure. It serves through SSL, so that the identity of where your code comes from is secure. And in fact, I probably shouldn't even go through the whole can of worms of what is security on the web, because it is a big can of worms to talk about. But anyway, talking about cookies specifically are a particular way to move information from one place to another. Now, I'm not sure if it'll work correctly here, but let me see if I set this to HTTP only and then refresh the page. You'll notice that document cookie, I can't actually see it. I can't actually see that cookie that I marked as HTTP only. So that's like an aspect of the security side of things. Is that way you can keep certain things secret from the JavaScript while still using them for, say, authentication, like making sure that this user is authentic, and then you can authorize against them. Authorize them for some images or something like that. So yeah, that aspect of images and just general requests where you can't put in some information, because the only other alternative would be able to do something like authenticated user token or something like some sort of authentication token, and then you use this particular string here to check whether that person is legit, right? Not necessarily ideal there. So that's the sort of where cookies come in. They give you a means to access some information, authenticate against it. Oopsie daisy. All right. So cookies live in that world. Local storage and IndexedDB are isolated. They are isolated to the host that you're on. Is probably the best word to use. And if I look at an application, you'll see I have nothing in session storage. I have nothing in IndexedDB. And we're primarily going to talk about IndexedDB. We're going to primarily talk about local storage today. But session storage is essentially identical. The only difference is session storage is wiped out as soon as your browser closes, whereas local storage will hang around for as long as essentially Like you can close the browser, do everything, and then come back and it will be there. There are some sort of really rough rules in terms of clearing cache and whatnot, but local storage and IndexedDB are usually designed to persist beyond your standard clearing of cache and whatnot. Now, local storage as an API is quite a simple one. So let's take a look at it. I don't need this diagram anymore. So let's jump into let's jump into MDN and take a look at local storage. So here we go. The read-only local storage property allows you to access a storage object, which is an interface, for the document's origin. And the stored data is saved across browser sessions. So here, local storage is similar to session storage, except that while data is stored in local storage, has no expiration time, whereas session storage does expire. And also, it's specific to the protocol of the page. So if we were to say, save something to local storage here, and I was going to set an item, and this is just obviously a crash course in what the API for it is, but if we were to set an item, set item foo, and then if I were to get item, you will see that I have access to it. You can see that bar right there. Okay, but what if I was to change, oopsie daisy, what if I was to change, say, where the server ran, right? So let me see how to change, it's probably just port. Let me just change port. So if I was to change the port to 8070, and then close and open gulp. So now we're running on port 8070. And I was to try and run local storage get item, you can see it came back with null because it is not there anymore. And the reason for that is because what I'm able to access is limited based on the URL that I'm at and also the protocol. So all of this sort of origin. So if we go to window.location.origin, this entire string here needs to match perfectly for me to be able to access local storage. If I close the server down again, bring us back to port 8080, which was the default. I can't access 8070, back to 8080. And now if I go local storage get item bar, you'll see that it's right there, okay? And I can also inspect it using Google Chrome's developer tools. See, that's in the local storage, but not the session storage. And just to demonstrate how session storage gets rid of things, if we just set item foo to bar, and we take a look in application, we should be able to see it right there. Now, if we were to refresh the page, we can see that it's still there in session storage. However, if I close the browser entirely, and I'll open up again, hopefully Chrome doesn't make me a liar. So you can see it's now absent from session storage, but still present in local storage. So there's our difference. Now, we have IndexedDB and local storage. So what's the key difference between them? Well, if you're from the backend world, it would be the difference between, say, Redis and MongoDB. Probably the easiest way to talk about. They're both NoSQL databases, and NoSQL is short for No Structured Query Language. And I guess the difference between them, if you wanted to sort of break it down in terms of, I'm thinking how low level to talk about this. So local storage is a key value store, which if we were to talk about data in general, just going to make a random file here. So local storage stores data in this sort of format. So that foo that I talked about gets stored as bar, okay? And say there's some other key, so let's say key 2, something like that, and it has a value 2. So all it has is essentially strings associated with other strings. And when you want one of those things, you go and get one of those items and they come back. It provides you back a string. Now this is a part of the local storage API, right? So let's formally talk about that API, right? If you want to set an item in local storage or session storage, you call local storage, and then you set an item. You run a function called setItem, and you just tell it what the key is and then what the value is. So as I said before, the foo, the bar, that gives us, that gives us an item. Now it doesn't actually return it or anything like that, but now if I wanted to get that back, I could go local storage.getItem and then foo. Now there are some important things to realize like this. Like we can pretty much throw anything in there, right? But when it comes back, it's not gonna come back as the type we want. It is literally string to string. So you can see here where I chucked in the number 12, when I got the item back out, it came back as a string as well. So we can put in pretty much anything, but it will come back. What did I do wrong here? I set item instead. So if I put in a boolean and get it, you'll see it came back as a string. This is important because when we work with this stuff, we want to be sure that what we get is what we put in there, right? What if we put an array in there? I don't actually know what happens, but let's see. Okay, so that is the string representation of that array, which you'll notice actually gets rid of the concept of the array. So we'd have to know for sure what's going in there, right? What about an object? What happens there? So here you get the string coercion. So realistically, all that happens is whatever goes into set item, it gets to string called it, and that's actually the result that you get in at the other end. And just to be clear on that, I guess, like if we throw this together and run toString on it, you'll see that that is in fact the result of toString here, just the same as that there. So it removed the square brackets on the outside and just comma separated them. All hunky-dory, right? So it as a storage method, it has fairly low utility. But it has some key things that make it better than IndexedDB in a number of cases. So document.cookies has a terrible API, and local storage has a limited API. But the key thing that makes them stronger than IndexedDB is they come back immediately. They're synchronous. Anything that we do with IndexedDB requires us to wait some period of time. So we need to put in promises and all of the complexity that entails, especially if we're fetching a large amount of data. And that totally makes sense when we're looking at a large amount of data, because we don't want to lock up the whole browser while we're doing a database query that pulls down 100 rows or something like that. But we do have to do it. But while we're talking about the difference between these two storage mechanisms, I should probably talk a bit about IndexedDB. IndexedDB is a database. Okay, it's not the greatest of databases, but it is a database. And what that means, it has a concept of tables and rows. And I wonder if there's a real easy way that I can put together these bits and pieces, just to sort of try and demonstrate some of it. Yeah, it would take a while for me to talk about this one. Really, it's been a while since I've written a library on this one. Um, yeah, that'll do. Let's try and open a database, and we'll see what happens here. So let me clear this out. So that was playing with local storage. Let's play a little bit with IndexedDB. So IndexedDB doesn't give us a whole lot to work with. We can open a database. So let's call it TestDB. And it's pending there. Ready state done. That's great. If we refresh, we might have ourselves a database. So it created a database and that's great, but there's nothing inside the database. Okay. So after that, we need to give it instruction to actually create things. Oh dear, partial support. Unfortunate. Anyway, once we've created our database, then we have to do things to work with it. And database, so those of you who are familiar with a conventional database would be familiar with the concept of a table, and then inside rows. So the top level construct is the whole database, and then inside it there are tables. And inside tables, there are rows. And usually the tables have a concept of columns or fields or something like that. So the idea is that your data is always going to fit into some sort of structure. So if you were to have a user model, then maybe that user would, you would have a user table. And in that user table would be like they would have a series of columns for each row, and the column might be user ID, and then maybe their full name, maybe their preferred name. And if you're in a typical structured query language database, you would have types for these. So you would have probably more definitive than string. They usually use varchar, which is variable character length, and might say exactly how long it's meant to be. And then you also might have something like a bio. Now might be more of a text field, which means that it can be of any length. But either way, you have to specify what the fields are. And that's for a SQL database. For a NoSQL database, you don't have to do that. Usually, you just maybe say what tables there are, and maybe say what indexes you need to be able to search on that data. So you might have an index on the user ID and maybe the full name, and that's what you search for particular items for. But IndexedDB doesn't use that nomenclature, so it uses the idea of object stores. So let's see if we can just create one. I'll bring the documentation up side by side so we can sort of play with it. Okay, so, and the interesting thing about this is the concept of needing having events and whatnot. And I'm just going to steer clear of events, to be honest, and see if we can just do this manually. But it has been a while since I've played with this, so let's see how we go. So if we open testDB and assign it to the variable DB, so we've got an IDB open request. Let's see if we can create object store. Doesn't look like we can, but you never know. DB create object store is not a function. Okay. Yeah, so this is going to get a bit tricky to demonstrate in this way. So I think we'll leave it for now. Because when you interact with a database rather than a like local storage, like a database has various rules, right? When you access a database, you need to tell it whether it needs to upgrade to a next level of a schema or something like that. So you'll give it a version number, and then that version number will let it know, okay, you, the browser, needs to update your data to another level. And like you might add some tables, add some indexes, and that kind of thing. And that just doesn't make it amenable to sort of like bit by bit programming. So we'll leave that as a concept for now. But either way, IndexedDB is more complex, but gives us a lot more power to store a lot more information. So we will need to make a library to work with it eventually. and we'll do that. We'll pretty much start that next week. But for today, we're going to focus on local storage on its own. So local storage is a key value store, which means, as I said before, you provide a string and you get a string in return. So that's all well and good, but there are some sort of sharp edges to the API that we sort of need to deal with. Some of these are browser vendor imposed, and some of these are just the nature of the beast that we'll have to work with. So if we make ourselves, we're going to make a directory inside client, and then platform, and then persistence. Platform, and we're going to make a directory called persistence, and that persistence is going to represent eventually our local storage and our IndexedDB. We probably won't talk about cookies too much. We'll only use that as a server-side authentication pattern. So yeah, this is going to be all about local storage and IndexedDB rather. Where are we going? Persistence. And we'll make an index.ts. And what I'm going to do is I'm going to write the usage code first. So we're just going to put together something. Let's think of something really simple, right? Let's think of something that, let's say it's going to take, let's say it's going to always, whenever the store updates, it's going to persist the value of that counter. That feels like a fairly straightforward example that's going to work for us. So you can see that number 0 there. Every time we refresh, that gets lost. Let's persist that instead by using this persistence layer. So what we'd probably want, and we're going to break the type system as soon as we do this, but that's fine because I want to write usage code first. So let's say, what can we even call this? We could just call this local storage, and that would be cool. Get local persist maybe or something like that. How about I get an object and I'll call it local storage, and we'll get that from persistence. I don't want to be particularly we'll call it key value storage actually. That way we're really specific about the type of storage that this is. Okay, so, and then we're going to get that from persistence, although it's going to complain that it can't find this, and that's fine. As I said, the type system's going to blow up while we do this. And every time we update the counter, we're going to talk to the key value storage, and we're going to set a particular value. And that value is going to be, say, counter. We'll call it counter persist, just to be, we don't have to be massive about it. Okay, counter, and we're going to persist the counter as exactly state.counter.count. And that's pretty much it. And then on the other end, we're going to want to get that key value storage, get that count. So we're going to get that counter, and there's already a thing that we're going to be running into here, which I'm doing on purpose because I want to bring it up, but I won't spoil the surprise for anyone who's raising their hand up in the air and is not entirely sure what I'm talking about here. Yeah, so here's what we want to be able to do. We want to persist some sort of counter, and we want to be able to pull that counter back out. Sounds straightforward enough, right? And we'll just write it in platform persistence index.ts for now. So what name did I give that? Key value storage, right? So we're going to set key value item as a function. We're just going to open up the functions and then provide them all finally as some sort of export. That's what I'm going to do just for now. So if we start off, we've got the key, which is a string, and I'm going to see if we can get away with something where the value is literally anything and actually comes back as anything. And we'll delve into this a bit more. So get key value item, and that will give us a string and return anything. And we'll just have to be responsible for setting the type properly on that with whatever's making use of the key value store. And then finally, we're going to export a constant called key value storage. And inside that is going to be set, which is set key value item, and get key value item. And we'll just see if that's getting called correctly first. No, I didn't like that, did it? Cannot read property to string of undefined. So that's one partial thing that we're clearly missing here. What if the value doesn't exist? Should we perhaps supply a default like that, perhaps? That sounds like a good idea. Let's do that. So how about default value, and will equal 0. And that default value can be anything. And we'll just return that default value for now, just to get things working properly. All right. So that works. I mean, that's fine. And we're setting a counter, but that's not actually ending up in our local storage yet. So let's take that next leap to doing that. So we're going to set item, and that's going to be key and value. Now when we get counter, we also need to get it, right? So so we'll use local storage to do just that. And get item from key. And we'll see what that looks like, hey? And I might change that default as well to null. Be really definitive about the lack of existence of that particular thing. Okay. So the interesting thing about that is we actually end up with it working, but it's mainly because JavaScript's type system is really weak, and it's quite happy to just call to string on a string when it starts off. Sort of like that. You can see that it's a string and you call to string on it and it works just fine. So it doesn't complain or anything like that. But if we had a look and say console logged what came out of it, oh yeah, actually you can see it right here. You can see right here that that number there, it doesn't even update the count. That's funny there. Oh, because I'm only returning default value. So how about we, how about we return value or default value? That's kind of a misnomer because it's more like if value equals null, then do one thing, then default value, otherwise value. I've got to say, I'm not actually, let me double check what local storage returns when the name isn't known. Yeah, so null will do it. So here, we're being really specific and saying if value equals null, then return default value. And that's an important concept right there because the the thing about just going, and this is a constant pitfall, the concept of using OR for defaults, say this string, when you use OR, it skips over falsy values, right? So 0 or true equals true, 1 or true equals 1, 2 or true equals 2. You can see here for this truthy value it's all good, but what if you actually wanted the number 0? Then you need to be sure to check against very specific cases. So that's why often it's better to check against null than it is to check against just using or anything like that. Anyway, back to the task at hand. So this technically works, but the one big pitfall of it is it doesn't preserve types. But maybe we can figure out a way to get around that. Like we couldn't, so just to be really clear, we couldn't get around something like, say if we wanted to preserve counter instead. And this is where it gets interesting, right? So say if we wanted to preserve counter and then use initial, so we'll use counter state bundle dot initial as sort of the default value for initial counter. What if we did that, right? Okay, this is going to break terribly, which is, you know, one of those pitfalls of this kind of thing. Let me turn that off just for the moment. I'll turn off both of them, eh? So what if we wanted to preserve types and make it so that this count comes back? Because you know that the moment we turn this off, it's going to explode, right? Because when it got stored as object. It got stored as toString of that particular element. Well, let's backtrack out of this and think about how we could potentially preserve the types. So when we talk about data, passing it back and forth from a server, and also storing it for bits and pieces, you might have heard of the concept of JSON, or JavaScript Object Notation, which, this is a terrible thing to show up, but essentially JavaScript Object Notation is the way that we show information in JavaScript, but also it's a way that we've passed information back and forth from web apps for a good long while now. It's sort of replaced XML as the de facto standard these days. Well, JSON might be a pretty good way for us to make use of sort of preserving how things are supposed to be for a structure and object that we put into local storage. Like, let's test that out, hey? So what would happen if we were to stringify? So there's a JSON module that's standard on every browser. And let's say we were to stringify 12. Well, it looks like it came up with this string that's 12. Well, could we pass it and get the number back instead? So that there is a number right there, okay? It's a number type. So if we were to very strictly run an equality check on it, it would not equal 12 as a string, unlike that, where if we use an unstrict equality check, it won't work. It will work rather. But see, if that's the thing, how does strings work in there? Well, strings probably work something like this, where you can see it's actually preserved the string inside it. And then if we do JSON.parse against that, how do I do this? Let me get rid of that. Escape that. Okay, so you can see that parsed correctly and created us a string. If you're not sure what these backslashes are, they're essentially a way for us to put quotes in something that is surrounded by quotes. We could have also done something like this, where we quoted it on the outside with single quotes, and then on the inside we used double quotes. That could have also worked. But either way, JSON parse and JSON stringify give us a means by which we could potentially get a bit more complexity into this, so we could store more complex things. So there we got something, really straightforward. So instead of setting an item and setting that value, we're instead going to use JSON.stringify to store a more complete version of that value. And we won't ever be able to put anything complex in there that's like classes and objects and needs to be hydrated, it's called, with extra behavior and whatnot, but we don't really need to do that. I just want to be able to put something with more structure in it than just simple text-to-text key values. So now if we do that, and we have a look at our application storage, you will now see that counter looks good. Okay, it looks like the value that we actually want to have access to. So all we need to do on the other end of that is give ourselves the value back through local storage get item. Now here, we've got this concept of value equals null. So we're going to treat null as what happens if we literally didn't get anything back. And then the alternative is we can go JSON pass on the value if we did get something back, if we did get a string. And this is interesting because it should mean that we should be able to do things like get back null and that kind of thing safely. But I'm not entirely sure how JSON stringify works with that. It might not like it a whole ton. Let's have a look. JSON.pass on null seems to work, so maybe it would work. So if we roll with it this way, now we should be in a realm where we could keep this counter state, this entire counter state, in good order all the time. So we'll increment a bunch of times and we should persist it. And that's all very well and good, right? All good. We've got it running. It does a bit of parsing and that kind of thing. There might be potential that I'd have to look into browser support on this in terms of all the various browsers. I'm not going to be leaning on it too heavily in terms of how structures get stored in here, so I'm not super worried about it. But once we start doing all of our browser testing, we'll have a good look at it and make sure that our key value store is pretty hunky-dory. So that's pretty much why I wanted to talk about a whole lot of other stuff today, because that is the extent of our local storage code. We may as well implement some ability to clear the information. So let's have a look at the whole API for local storage and see what we've missed. So the key ones are remove and remove and clear, I guess. So let's clear those two out. Let's sort those out. So function remove key value item. And here we'll just essentially do just that. We'll go local storage dot clear, remove item. And we'll use the key. And then finally, clear key value storage. I'll just use clear key value. And that won't have anything attached to it, just run clear. It's a void function. And that will get rid of pretty much everything. So when you look at this, you might go, all right, why on earth did you wrap this? Why on earth would you need to wrap this? Well, there is one unfortunate caveat, and it's all Apple's fault. So if we look at support here, I mean, it's supported by everything, but I'm pretty sure, let me double check this, because maybe maybe it's changed. But I doubt it. Yeah, so it hasn't changed. So this is a very specific issue with local storage when it comes to Safari in private browsing mode. And that very specific issue is that it just crashes. It just dumb crashes. That's it. It doesn't work. And the reason for that is because in their infinite wisdom, they decided to, rather than completely... This fix affects normal private browsing mode. Now work in Safari 10.1 and later. Okay, it has been fixed, but maybe we'll still get caught by the older versions. And this issue is essentially specific to private browsers, and when private browsers are used, rather than allowing you to store it and then just wipe it, which is what you'd think would use, like whenever you use private browsing, there's sort of cookies that are local and browser storage that is local, and the moment you close all the tabs and clear the session, it all behaves like session storage. But yeah, for a good while it didn't work, right? It crashed instead. So let's think about how, if this local storage system didn't work, how could we provide some sort of backup way to handle it? And just assuming we didn't need the persistence, we just wanted to keep on working, then maybe what we could do is we could provide some sort of a key value store. And essentially for all of these, we run a little bit of exception handling. And for all of them, it's essentially if window.localstorage.setItem, if it doesn't like what it's doing and it breaks or whatever, then instead of doing that, we can just put on the key value store something with key and then value. So we just put on the key value store the item that we want instead. And we'll type that with key string any. So that gives us a backup in that case. And then for get value item, again, we're looking at the same deal, right? So we just figure out what the fallback method is for that one there. So in this case, it will be a case of if key value does not equal undefined, because it would be undefined if it wasn't found there. So if key value does not equal undefined, then return key value store key. Else, you can return default value. And that will be good because it means that it will always return null when the item doesn't exist, which is the default that window.localstorage.getItem returns. Now remove key value store item. Remove key value. The way we'll handle that, essentially the same deal. This isn't the greatest of fallbacks because I don't know if try catch works for all of these things. Potentially what we could do is like sort of say yeah, in fact that might be a better thing, just because the whole depend on an exception for every single one of these is potentially a little bit fraught. What we can instead do is for any storage ones, we use fallback needed. And then from there on, we use get key value. But that's not actually great either, because if we get stuck in this position where we're trying to depend on this, but it's not existence. Oh no, it's fine, it's fine. I was just thinking like what would happen if you were depending on something and you wouldn't get it. But the thing is you wouldn't find out about it anyway. Like if fallback is needed and the item, so if you haven't stored anything yet, and fallback needed is still technically true, you wouldn't have anything to get from the key value store anyway, so it's fine. So it's fine all around really if this happens. And I've got to reverse that, so if not fallback needed rather. And then the else here is to delete from key value store key. And if not fallback needed, then do this, else we're just going to I'm just going to essentially reset it. So I might just use let instead, just to give myself license to do it. Look, don't want an array, I want an object. Okay, well that's pretty much my local storage API. I could make something prepared for session storage as well. So persistent key value storage versus session key value storage. If I did that, then I'd pretty much be done with local storage, and then we can launch straight into IndexedDB. So I might just finish that up right now, and then we'll go from there. I'm going to separate these into files now that I've had my little play. So client, platform, persistence. Chuck that in there. So here's a thing. I'm kind of cool with this having duplication in it because I'm really not going to write it again. If it was more often going to change or anything like that, like maybe I'd have some sort of abstraction so I could say, oh, this is session based and this is not session based and stuff like that. But I'm not going to use this API enough the way I envisage it to really care that much about how different these are. So I'm really just going to get it laid down and figure out how to make use of it down the track, okay? So instead of that, we're going to export default, which is going to be this object here. So that's the session version. It's all local storage. No local storage in there. We'll go to persistent key value storage. And again, we've got a default. And now in here, I'm going to grab my persistent key value storage. Session key value storage. And export them, and then we're all hunky-dory. Now, if we look here, because key value storage is going to be my prominent, most usual way of doing this, I'm going to have key value storage be sort of the de facto default choice, and session key value storage be the one that we fully name. Cannot find name key value storage. Oh, it doesn't like that, does it? Ah, right. Yep. Export default. There we go. Oh, no, that won't work. It doesn't like that at all. So let's do export const key value storage equals persistent key value storage. And then we'll do export constant session key value storage. Actually, I can do the shortcut with that one. It's exactly the same name. And now this should be well behaved and should be still working. We refresh, everything seems to be all in good order. And we could test local storage clear and session storage clear, but I mean, I'm sure you can see that these are extremely trivial examples, and I will worry about it if things break, but I'm not too concerned about that at present. So that leaves us with a light bit of persistence for our counter, and then a bit of a springboard into getting into IndexedDB proper, which is really the meat and bones of persistence. It'll probably take us maybe all of next week to get some sort of layer that we can work from. But this will give us a foundation that we can go from to actually build our proper application and our state. As I said before, and I said this I think at the tail end of last stream, but the foundation of any sort of major elephant of development from my standpoint, if you get the data right, the code is what makes the data work. But if your data is right, if your data is severely flawed or has issues, you just have to write way more code than is necessary to actually get things to work as you intend them to do. So having a really good storage layer and a good data model to underpin your application is so crucial. So we'll be getting into IndexedDB next time we're around, and that will give us a good foundation to build the rest of the app on top of. So let's make ourselves a commit. Didn't do a whole lot, but we did do a little bit. CD client, is that where? Yeah, let's remove data.js. That's no use to us. And let's commit this. That's pretty much it. All right. So day 9, implement wrapper for local storage and session storage. It may be a question, why on earth would you implement something so trivial in a wrapper? Why wouldn't you do it directly? Well, in the past, it was to deal with ugly bugs like that one in Safari browsers, or WebKit rather, where in private mode it just basically flat out didn't work. You couldn't use that API. That's kind of not acceptable. Like if you are using the API to get some sort of key authentication token or something like that, even the absence of that token, you need to still use. You still need to have some sort of storage there, and if your whole app depends on it, it's no good if it just sort of disappears like that. So you need some sort of fallback, and that's what that wrapper allows us to do. If you're always talking directly to every single web API, there is potential that if one browser doesn't play ball, suddenly you just can't either use that feature, or you have to think about how you're going to use that feature in a way that's maybe not beneficial to your application. So just by putting that wrapper in there, and it's the same with our IndexedDB code. If we're using IndexedDB directly all the time, it's potentially going to give us issues down the track. Anyway, that pretty much covers it for today. We'll be back into things on Tuesday at 8 p.m. Australian Eastern Standard Time, where we'll be getting into our IndexedDB, building out a proper database, a whole schema and all the works, and it'll be good. Get us set up for our next phase of development. So thanks for watching. We'll see you around.